Hello, my name is Patricia Souza, and I'm researcher at C3P. And this solution is called Ptasc, which is for provisioning, authentication, and secure communications between Internet of Things devices. This solution has a manager that represents a certification authority and a secure token, which is represented by a YubiKey that generates one-time passwords and the public key to the target devices. So the benefits of this solution is to have device identity, scalability, offline cryptographic assets, revocation, possibility of dissemination, and is secure against man-in-the-middle attacks. The first step is to configure the manager. This manager issues the certificates that will attest the trusted devices so that they can perform authentication between them. So it represents a certificate authority and a one-time password to server to verify the keys that are sent from the device that is being authenticated. Then this process of authenticate new devices starts by the owner inserts the secure token into the target device, and then this new device is added to the pool. The new device starts by sending the certificate signing request of itself, which contains only the public key, not the private key, so this private key has not been compromised. When the new device sends the certificate signing request to the manager, the latter will produce a signed X509 certificate. Furthermore, it also sends one-time passwords to verify that the new device is in physical presence with the secure token, and is, therefore, the correct device to authenticate. After the authentication is successful, the manager device sends back the signed certificate to certify that the client is a secure device that can be added to the trusted device pool. These certificates are used to establish trust between the new devices and provide decentralized secure communications between them without the intervention of the manager device. Then we have decentralized peer-to-peer communications. So the manager here acts as a dynamic certificate authority that must be turned off when device registration is not required in order to eliminate the single point of failures. For mutual trust between the devices, after the authentication with the manager, both devices must exchange the manager's signed certificates. After verifying the authenticity of these certificates, a symmetric key is generated between both devices to establish a secure communication. We use elliptic curves for this communication to encrypt the messages. Then we can merge two trusted pools. So here, an identity and authentication solution must be flexible and highly scalable enough to handle billions of devices infrastructures in multiple environments. To address this issue, the system replicates the traditional mechanisms of having multiple certificate authorities supported by a client. So, to allow two pools to connect to each other, both managers perform mutual authentication, as seen in this image. After this, the next step is to spread information across devices among different pools. To do this, the manager must send the signed and encrypted information to the devices. This allows any of the devices to read information and verify the manager's signature. So the figure represents the agreement between both managers and the corresponding spread of information from manager to their peers, so their devices, when they begin to trust to each other, and can announce on the network that others should move to include these new trusted peers in their trusted network. So what this guarantees in terms of security? Basically, the secure token generates one-time passwords and stores manager's public key to prevent tag impersonation attacks. Because even if the attacker could change his name, it must have both data, the authenticated one-time password and its public key, in the physical secure token, which is impractical. The one-time password prevents replay attacks and man-in-the-middle attacks from already authenticated peers because the secure token uses a set of volatile and non-volatile counters that ensures that a one-time password can no longer be used after being validated once, as a YubiKey basically. And also secure token prevent man-in-the-middle attacks from unknown peers because this approach uses a secure token with the receiver's public key, so it is transmitted only over the USB. Thank you. If you need further information, you can contact me to the email that is in this slide.